All right, guys, let's do number 47. A pendulum with a cord of length 1 meter swings in a vertical plane as shown in this figure. When the pendulum is in the two horizontal positions, 90 degrees and 270 degrees, its speed is 5 meters per second. Find the magnitude of the radial and the tangential acceleration of these positions. Draw a vector diagrams to determine the direction of the total acceleration for these two positions. Calculate the magnitude and direction of the total acceleration. I encourage you guys to pause this video and to give this problem a shot. Presuming you pause this video and give this problem a shot. All right, let's draw this pendulum. So you have this thing right here. You have a pendulum that swings, and it has a radius r. R is specifically 1 meter. Beautiful. And you have an angle. And the angle, I don't know what angle it is. You have the force of gravity, which is 9.8 meters per second square. So, and G is going to be 9.8 meters per second square. Beautiful. All right, so imagine this pendulum swings at 90 degrees. And this is going to be 180, 270 degrees. So it's either of these positions, but I'm only going to... So I'm going to rechange the drawing here. And this is going to be the R radius. Gravity is going to be pointing downward at 9.8 meters per second square. So you have the gravity that's going to be pulling downward. That's as it's going right here. Momentarily, the centrifugal acceleration, believe it or not, it's actually zero by the looks of this. But the moment it's going down, and the moment it's vertically on this side, as much stretch as it can be, it's going to torque, it's going to provide this component of the acceleration. And the question for part A is asking, let me move that out of the way, is asking, find the magnitude and the radial of the radial and the tangential acceleration for these positions. So this is going to be a tangential. A tangential is simply just going to be 9.8 meters per second square. A radial is depending on the speed, and also keep in mind the speed varies, but in this at that particular point, I know I drew a little here, but realistically, let's just pretend this is a 90 degrees. Stretch it all the way out there, and 90 degrees, so this thing is going to be at, well, b squared over r, or in this case, so a tangential is going to be at 9.8 meters per second square. Beautiful. A radial is going to be 25 meters per second square. You could do the math in your head because velocity is 5 meters per second. 5 squared is 25. 25 divided by 1 is just really just 25. So there you go. That's part A. So find the magnitude of the radial and the tangential acceleration of these positions. So I guess that we just solved for that. All right. Fine for part B. Draw the vector diagrams to determine the direction of the acceleration of these two positions. So one moment it's going to go in this direction, and then the other moment it's going to go in that direction. And this is going to be the A tangential right here. And this is going to be the A radial. Beautiful. All right, we're done. All right, so let's do what part C. Calculate the magnitude and direction of the total acceleration. So A radial is going to be the Pythagorean theorem, AT squared plus A radial squared. Put that thing together. Get your AT out of your calculator. So once you calculate the centripetal acceleration, you should get 26.85 meters per second square. Beautiful. And the tangent is going to be theta, which is going to be 21.4 degrees. And I don't know, I didn't really keep track, but I think I took, what did I did? I took 9.8 divided by 25, so I think it's 21 degrees here. Oh, no, wait. No, it's right here. So this is 21 degrees right there. Anyways, you guys can... Anyways, I'm done.